Hey guys, let's go over this practice test. Get my pencil here. And this is the Chapter 3.1 practice test, March 31st, 2021. You can always write your name in there. Mr. Ing. Whoa, whoa, whoa. Where's my, hello? See, it's not. Whoa, it's like. Maybe it doesn't like orange. Okay, let's try a different color and see. Answer the following questions about inverse functions. What does it mean for a function to be invertible? It basically means a function is invertible. I'm going to change colors so you can kind of see this word here. Invertible if it's inverse, if its inverse is also a function, Okay? Alright, 1b. How can you use the vertical line test and the horizontal line test to determine whether a graph represents a function and whether the graph is invertible? Alright, so I'm just going to use the word VLT. If the graph passes the VLT, means a vertical line crosses the graph at any point once. I'm going to put that in capitals because that's a big idea. Then the graph is a function. Then graph is a function. So I'm going to again capitalize it because it's a big idea. Alright, if the graph passes the vertical line test, it means the vertical line, we didn't write line, crosses the graph at any point once, then the graph is a function. Alright, let's try orange. I didn't like it before, but what about this horizontal line test? Basically, if a graph is a function, and it passed the VLT, and then now, and a horizontal line, oops, ran out of space. Line passes through graph once, then passes the horizontal line test, which means graph has an inverse. Graph has inverse, or another word is it is invertible. Okay? Alright, question 1c. If a power function is invertible, what type of function will its inverse be? If a power function just means like something to the second power, and there's no numbers in front or behind it, that would be a polynomial. So power function is just this, okay? There's nothing before it, or there could be some before, but there's nothing after it. If this power function is invertible, meaning it passes the horizontal line test and the vertical line test, then its inverse will be what is, remember x to the second is a parabola, right? And then if you actually apply the rules that we learned, then it'll be a radical function. You know, the function you're looking for is now looks like this, and that graph looks like that. Okay, so you're going from this parabola x to the second to something called a radical or square root. Okay, all right, let's take a look at 2a now. Consider the function f of x equals x squared. So we kind of know what that is. That is the parabola. Write the domain. Okay, let's just get a new graph. Okay, remember, domain refers to the x-axis, this one here in orange, and I like to say that you go from left to right. Okay, so let's get a graph on here. The parabola was supposed to be like this. That's my graph, y f of x equals x squared. It is a parabola like this, right? And some hints you can write on here. Negative infinity to positive infinity. Let me zoom in for you guys, right there. Okay, so as I draw these, let's do pink. As I draw the pink, right, the first thing it touches is that arrow. So the x values are coming from the negatives. Still touching, still touching, still touching, still touching. The last thing it touches is that positive, or the last arrow is just going towards the x numbers that are positive. Okay, so the domain in interval notation is just going to be, look, watch this, guys. Boom, negative infinity, comma, to positive infinity. That's your answer. That's too big. Okay, super spread out, but I kind of wanted to show you visually that graph. Okay, what is the range? Let's draw another graph of the parabola. Okay, now the range, let's do pink. The range here of f of x refers to essentially the y-axis. Okay? And I like to have a phrase called bottom to top. Bottom to top. Okay? Let me show it to you, right? So if, let's write, negative numbers on the y-axis and positive numbers. Remember, I'm focusing on this y-axis right here in blue, okay? So as I go up, nothing, 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 stop. The graph from the bottom to the top just touched this point. On the y number line, that is the number 0. Okay, and we keep going up, and the last thing it touches is the arrows, which means all the bigger numbers. So I'm going to highlight the two numbers that we have, 0 and positive infinity. So the range on this problem is going to be from 0. If you could turn your head sideways, you'll kind of see this number line, 0 to positive infinity. Remember, with a 0, it is touching a closed circle, so that's going to be a bracket. And with the positive infinity, anything negative or positive infinity is always going to be a parenthesis. So that is our answer for, notice I'm boxing my answer so you can kind of clearly see that. Let's do 2b. Is this function invertible? Explain how you can use a graph or a table of ordered pairs to answer this question. All right, let's talk about how do we use the graph, okay? How do I know by the graph, is it invertible? Graph is not invertible. Why? Because it would fail the horizontal line test. And again, let me show you guys the horizontal line test, HLT. Why does it fail? Because if I take this white line here and I go across, it's going through that more than once. Okay, so that's how you figure out the invertibility by graph. Okay, let's do it by now. Table of ordered pairs to show you that. Okay. All right, so if you just make a bunch of values for the graph up here for the parabola, right? That would be the reference points back from back in first semester, and we talked about transformations. Like you put in x equals 0, and you get a 0. 1 squared is 1. 2 squared is 4. Okay, so what I want to show you though is if you do -1, you'll get a +1. Okay, and you should see something that you have these repeating numbers on the ones. So if you notice, you'll have different x values. Do you see these right there? Oh, sorry, -1 and a +1. Those are different numbers, but repeating y values shows it's not. Whoa. Why does it erase it? I don't know. It's magic. Not invertible. Okay? All right, let's move on now to 2C. All right, guys, let's go on to the next page here. 2C. It says squaring function is invertible if its domain is restricted. So it's just kind of telling you some information. Write an equation, so I'm going to go ahead and highlight. That's what they're asking me to do. So we're going to write an equation for the inverse of the function of g of x equals x squared, where x is greater than or equal to 0. So let's go ahead and graph this. Visuals, always drawing a picture is super helpful. And here is x squared. It's just a parabola, right? But x is greater than 0, so if I go to the x-axis, numbers that are bigger than 0 are like something like 1. Where's 1? It's over here and to the right side, right? So basically what x is greater than or equal to 0 is kind of called a restriction of the domain, which basically means it wants to graph it to the right side. Okay, so if I take this orange one, and if I apply, what would the inverse look like? Well, you can do two things here. You can do this graphically, so I'm going to show you guys graphically. And graphically, it would just basically be doing our trick. And the trick we applied is rotate it 90 degrees counterclockwise or left. So basically, if this comes down this direction, so it would be right there in light blue. And then in pink, we would have to then reflect it over the y-axis. So the y-axis is right here. So essentially this would be my graph here. And I want to point out that the big idea of why we do this trick and why does it kind of work is that basically across this blue line is that this is y equals x. We're switching the y's for the x's here. And so that pink graph, so to answer our equation, what is the equation? Y, you could say something like the inverse. Sometimes you can say the inverse is with this notation, the little 1 there. Inverse of x is, what is that pink one? Is the square root of x. You could have said a different function, but putting up that little 1 up there, let's write that up there. This implies the inverse. Okay. Another way of doing this, algebraically, I didn't get to show you guys a lot, is algebraically, is if you take the g of x and you change this one to a y, And then I'm going to apply what I said over here over this reflective line. You're going to change every x and y values. We're just going to switch the places of these. And then basically what we're going to do is we're going to solve for y, which means get y by itself. So I take the square root. And then I'm going to have the square root of x equals, remember this is a 2 here, and these cancel. So you're just left with a y on this side. And then you can change that, you can change the y back to the inverse of the function. So 2 ways, algebraically or graphically, how to get that equation. Okay, 2b, write the domain and range of the functions g of x equals x squared, x is greater than or equals 0, which we did in the previous problem, and its inverse. Okay, so let's just do, we already have the graph here, and I'm going to do the restriction, which we did in light blue, in pencil light blue. I don't know if you can tell the difference. So that was the one, well, I guess really it was orange up here. You guys see that one right here? So the domain for this one is, if you're going from left to right, from negative infinity to positive infinity, and the graph's already messy. Let's create a different one. The graph looks like, well, orange. And the graph on the x-axis is not starting until right here, which is 0. Which is 0. So where's my, there it is. So the domain is going to start at 0, and this is a closed circle, so it would be a bracket. And the graph keeps going until you hit that arrow, which means not going up, but just that the values are going towards the right, towards positive numbers. So that means that basically there is a point at, say, 100 and 100, right? So that would be positive 100. And remember, always with infinity would be a parentheses. Let me erase those lines for us. Okay. The range is the bottom to top, so essentially what we're doing is we're just going from down here, and the same thing, the graph starts there at 0 to positive infinity. Oops, that one got erased. Alright. And let's now do the inverse. Let me go ahead and draw that graph. If you look at my messy graph over there, let's clean this up a little bit. It is the pink one above, so let's go ahead and just copy the pink. It's this way. Whoa, I know it looks different, but if you think about it, it's actually the same exact thing as the previous one. Why? Because you go from left to right. I'm trying to get on the screen to have both of those. Starting there at 0. And it keeps going towards positive numbers on the x-axis, right? And then, let me erase all those lines. Whoop, don't want that. And then if you do from the bottom, same thing. It's starting here at 0 on the y number line, so that would be from 0, and it keeps going, right? So the arrow, even though it's going right, what it's meant to say is that the numbers keep going up on the y-axis, so that would be positive infinity. So you'll actually notice that the domain and range of the g of x and its inverse are exactly the same. Okay, 2e, sketch the graph of g of x and the inverse of g of x on the same coordinate plane. Label the graph of each. Okay, let's just do that. So we said this one was orange. right? If you do, we're graphing again this one right here. So basically 0, you put in 0 for x, you get 0 as a y. Put in 1, 1 squared is 1. 2 is 4. And this is what our graph would look like. Something like that. And if I do let me actually do the coordinates. I think you'll see this. So 0, 0, 1, 1, 2, 4. Those are the reference points for a quadratic. But if we do on the pink, the inverse again, what you're graphing is y equals the square root of x. So if I make, you have to be strategic here. If you make 0, what's the square root of 0? 0. What's the square root of 1? 1. What's the square root of 2? Okay, that's not great. But if you did 4, what's the square root of 4? It is 2. And I want you guys to see, if I graph this, watch this. 0, 0, 1, 1, 4, 2. This is what my graph looks like. I want you to see that basically all we did was just switch those numbers. Do you see it? Switched from the orange. I know you don't see it there, but if you see here, and that goes back up to that idea of this reflective line. So let's go ahead and graph that reflective line so you can see it. Y equals x. Okay? All right. Let's look at 2f now. If the domain of the squaring function is restricted to non-positive numbers rather than non-negative numbers, another invertible function can be created. H of x equals x squared, x is less than. Write an equation for the inverse of that function. Okay, so let me see if it's going to make me go through all the... Yeah, I'm just going to go ahead and go down here and graph it so you can kind of see what... I like seeing the graph first. So if I do x squared, x is less than 0. Remember, this is the graph. And you're graphing this side, right? But remember, x is less than 0 is the left side. So if I can make that this point bolder, and then we told you about graphically, you're gonna rotate it 90 degrees counterclockwise or to the left. In this case, that would be this direction. So you would have something like this. Kind of hard to visualize. Okay, and then we would rotate, reflect it over the y-axis. So across this one, so okay, now what does this graph actually look like? I know it's kind of confusing, but I'm going to put this one on there too. Well, this one is the square root of x. And this is essentially the square root of x, but reflected over the x-axis. How do you get something reflected over the x-axis? Well, if you remember your transformations, all you have to do is put a negative in front. So that's the answer for this one. H prime of x would just basically be the negative of square root of x. Write the domain of this, and it's in interval notation. So let's just write it over here because we have the graph, and then I'll just copy and paste and put it up there. So for the blue here is the inverse of, no, that one is h of x. Okay, so here the domain of the blue is it's coming from the left side, so that would be negative numbers, but it stops at 0. It stops at 0. And the range would be going from not negative numbers. It would start at, here, let me draw y. It would start at 0. That would be a bracket. And then it's going towards positive numbers. Even though it's going to the left, it's still positive numbers. Okay, so let me copy that. Whoops. Oh, guess you could just put it right there. All right. Okay. And then let's go ahead and do h prime of x. Whoops. Let's do this one. H prime of x is this one. Inverse of x. And that's the pink graph. So the domain, you're going from left to right, starts at 0. Bracket, because you're starting at a point, like right here, and then you're going towards the right, and the last thing is the arrow. Now pay attention, even though the arrow is below, it does not matter, you're referring to the x number line, so that would be a positive infinity. In the range, you have numbers here. The arrow means it's coming from negative numbers, and you stop at 0. So negative numbers to 0. Paste, come on. There you go. And that was, this one is the inverse of h of x. Okay, and then we already graphed h. All right. Question 3a, algebraically determine whether each pair of functions are inverses using the composition of functions. Okay. This one is the one where we would do the substitution into it. I don't know if you guys remember that. So if I basically can do it both ways, if I can take this and put it into here, so that one would be f of g of x. And if I do that, I would get this. Where's my pen? And all this is to the 4th power minus 4. And let's just see. So these would cancel. The 4, pay attention, the 4, the root of 4 and the radical sign are gone. So you're just left with x plus 4 minus 4. And so you get this one equal to x. Okay, now I'm going to do it the other way. I'm going to put in the f. It's kind of messy, but I'm just going to do it this way. I'm going to put this here to this x right there. Okay, so let me write the inside. Let's do the outside. So the g of x is the 4th root x plus 4. Okay, and now I'm going to put in this x here, f of x, which is the light blue, x to the 4th minus 4. I'm going to put that in parentheses, and I'll copy the white. Okay, I don't need the parentheses, so those are gone. And if the parentheses don't do anything, negative 4 plus 4 equals 0. And then if you're just left with the 4th root of x to the 4th, well, this 4 and this 4 essentially cancel, and they're just equal to x. Remember that you can think of it as like this. That's one way of seeing it. Remember the exponent becomes the numerator and the root becomes the denominator, and 4 divided by 4 is just 1, so just equal to x. And because they both are equal to x, then we can say they are the inverse by composition. Okay, that was the answer for number 3A. Let's do 3B. So we're going to do the same thing. I'm going to take this 2x minus 3 and put it in for this x. So I have 2 over 2x. Here's my substitution. They're in blue. Plus 3. And again, you don't need the parentheses because it's not by multiplication, so the negative 3 and the positive 3 are gone. So you're just left with 2 over 2x. Okay, pay attention. This is so simple, a lot of students miss this. The factors of 2 are 2 and 1, 2 times 1. So when I cancel the 2's, the answer is not just x, the answer is 1 over x. All right, let's take a look at this one over here. I'm going to use j of x. The notation for that is this. This is j of x, and then what we're putting in there is h of x. So I'm going to put this, basically all that, right here. So here's the 2. That's what I'm going to put in there, and then I have the minus 3. Minus 3, sorry. Okay, so I'm going to put 2 over x plus 3. Okay, I'm multiplying here, right? So you can just do it like this. And now you just multiply across, so 2 times 2 is 4, so I have 4 over x plus 3 minus 3. Okay, so how do you, rational expressions, how do you add and subtract these? Well, you can multiply anything times 1. I want the same denominators here. And if I do that, there's magic. That's one thing I like about the iPad. I can just copy this because we're running out of space. And I'll come up here. With a little bit more room to work. Okay, then I'm just going to distribute that negative 3. And because the denominators are the same now, I can have 4 minus 3 times x plus 3. And then now it's not 4 minus 1, you're going to have to use PEMDAS and just distribute, so that would be minus 3x minus 9 over x plus 3, and then I'm going to have negative 5 minus 3x over x plus 3. And the big idea is this is not looking good. This does not look like what? 1 over x. So we can say not inverse by composition. And that would be the answer for that one. All right, let's go on to question number 4. The time it takes a pendulum, remember a pendulum is like from your ceiling. Oh, I'm playing this new game with my son, or he likes, they call it tiki toss. There's a little ring. And to complete one full swing, so maybe from here all the way up to there, is given by the radical function. Let's just write down the function. T of L equals 2 pi times square root of L over 9.8. Where T is the time in seconds, okay? And L is the length of the pendulum in meters. I meant to write that in a different color. Determine the time. Okay, so okay, question. That's the question. determine the time is an unknown, but what color is it? Is it orange or pink? Is it in seconds, time in seconds, or length in meters? It's this one. Well, now why do I do that? Is because now I can say t is a question mark. That's what you're solving for. Solve. Okay? For a full swing of a pendulum with length, okay, 1.2. What is this now? This is our letter what? L. L is 1.2. Round your answers to the nearest tenth of a second. Okay, so I can put in L to be 1.2. So every L, you can put in 1.2, and we'll just copy the rest. Okay, a lot of students just get confused with that function notation here on the left side. All that's saying is time is a function of length. So based on what you put in the length, you're going to get a time. So it's okay if you just wrote t. But I'm going to keep the function notation, and I'll show you why that is. Okay, so something really nice here is you have this calculator-ready equation. Let me take a picture of this with my phone so we can put it into the calculator. And I'll show you guys how I put it into my calculator here. Okay, I'm going to clear this out. All right, I'm going to write 2, and then I'm actually going to use pi, so that's to the right of the above the division sign on the right side in blue, so I'm going to go second pi. Okay, the square root button is on the left side above the 7, second square root. Okay, my calculator has everything in there, but yours doesn't. I'm going to even put a parentheses in there just to make sure. So 1.2 divided by 9.8. Parentheses. Okay, if you want to get outside the radical, just press right and it closes it. And there I have a number. Okay, 2.199. 2.199. So t equals 2.199. And it tells us to round to the nearest tenth, I assume, right? So the tenth is just this spot. I have to look here. So t equals, when length is 1.2, our time is 2.2. That is our answer. Okay, number 5. Consider the function f of x equals x, the cube root of x. Describe the combination of transformations of this function that you can use to obtain the graph of all of that. Okay, so it says describe. Describe means what? Words. So I'm going to get the letters first. And what you can do is you can just put this right in front of it. Okay, this one is not the one in white, a g of x, that plus sign, right? So if you changed it, it's okay to do this. It's okay. You can write x minus 2. Okay, why did I do that? It's so that I can identify, okay, let me highlight in pink the minus sign. So the c value is, look at this, -2. And get a different color here. My d value is -2. Okay, with the d value of -2, I'm sorry, that's 6. With the d value of -6, this means it's going down 6 units. And a c of -2, because it's, you're going to go left 2 units. And remember my silly phrase, I'll write it out. Add to x, go west, or left. Right? Do you see the plus here? Adding to x means you're going to go left 2 units. And then the d value was add to y, go high. You are not adding here, so you're what? You're not going high, you're going low or down. Okay? All right, so that was 5a. All right, let's go over 5b. Describe the combination of transformations that you can use to obtain the graph of h of x equals 2 times the cube, that's what that little 3 is, that's called the cube root, x minus 3. Okay, same thing, I'm going to put the letters right above or below it. And you can start crossing off letters that you do not see. So for example, on the radical sign, to the right, to the outside to the right, there is nothing over here. So there is no d value. Okay, I do see an a. Let's take care of that one. A is equal to 2. I see c is equal to positive 3. Do you see how I'm slowly circling that? I want you to notice that the minus sign is in the formula. Okay, and then there is no b value, okay? B is to the left of the x inside, okay? There's nothing here, so I'm right there. There's nothing, right? There's no number. It's a 1, b is 1. That would be, there's always 1, but you don't need that. Okay, so what is an a equals 2 mean? It's bigger than 1, so basically we call this a vertical stretch by factor of 2. Vertical stretch by factor of 2. And remember the silly phrase from the last problem, are you adding x, are you going left? No, you're going what? Right. So this would be right 3 units. Okay? And last one, describe the transformations that you can obtain by the graph of this. Do the same thing. Let's write the letters. Alright, do you have d value up here? You have none, so no d. And inside the radical sign, do you have anything to the left of the x? No, so it's just a b, gone. So a is negative 1, which means what? Okay, when it's negative, that means it reflects over the y-axis. Take that back, sorry, that was the x-axis. And then c value is 4. So that would be right 4 units. Okay? All right. Number 6. Consider this expression. Cube root of negative 27 x to the 12th power. Extract roots and rewrite the expression using radicals. So my answer has to be a radical. And I'm just using radicals. Okay? So how would I do that? Now, how can you write negative 27? So when you multiply that number by itself 3 times, it gives you negative 27. Well, here's the neat thing. I'll show you in the calculator, but in mine you have to go to math on the left side, and then you're looking at number 4. And you can type in negative. Now pay attention on this graphing calculator, you have to go to the left of the enter sign, not the subtraction, which is above plus. So to the left, 27 can go out. The answer is negative 3, because negative 3 to the 3rd power equals negative 27. Okay, so let's write that. Negative 3 to the 3rd power times. Now, how can you write x to the 12th, and I want it to have a 3 there? Well, in powers, exponents, it is 4. Because if you wrote it out 3 times, does this make sense? Then each x is just 4 x's. Okay, and if you do this, there's 3 of them. This negative 3 can come out, right? So this would be a negative 3, and same thing over here. This x to the 4th can come out. Now I'm gonna check my EVO. Even, variables, odd, out. So do I have an even index here? I don't. So EVO doesn't apply. Okay? Okay, so that is our answer, negative 3x to the fourth power. Now, it's asking us to do the same problem, extract roots, rewrite the expression using powers. So essentially what that is, if you do what we did in the last problem, or in the very beginning, you can, let's just do it, so let's rewrite it. And I'm going to do something not crazy, but I'm just going to put all this to the first power. So I have negative 27x to the 12th power. And the numerator inside the radical is a 1. And the index over here is a 3, which becomes my denominator, the down part of the fraction. Okay, now what you can do here is you can, let's change, we have that 1/3, so we already did something like this, negative 3 to the third power times x to the fourth power times 3. And then you still have that 1/3 that we need to distribute, okay? Now, why did I choose a third power? Well, if you think about it, if I distribute this to each of these, you're going to get negative 3 x to the fourth, and then that 1/3. The properties of exponents allow us to distribute that power. And if you think about it, what happens, you just multiply across, you get 3 times 3. 3 times 1 is 3, and 1 times 3 is 3, so you're going to have negative 3 to the 3/3, and x to the fourth to the 3/3. And what's 3 divided by 3? Just 1. Essentially that cancels, right? So you're just left with negative 3x to the fourth power. And that's our answer for 6b. All right, let's take a look at Jenna here. To extract the roots from the radical, a square root of a6, b12, Jenna wrote the following. So which method did she use above? Did she use radicals, or is she writing them as rational exponents? She's using radicals, right, to extract them. She's using 6a, question 6a method. Okay, so she broke them apart. It's totally fine. Why did she choose 2's? Well, remember that visible number there, 2. That's a good idea. Okay, I see this sign. Let's copy it from above. I think she did this. And let's see if it's right this time. Just going to bring it down here. Of course, let me erase the... Okay. Is Jenna's work correct? If not, show how you would correct it. Think about this. Yes, Jenna is correct. Remember, over here, you could have done something like a to the third, 2 over 2, and b to the 6, 2 over 2. And these cancel. Now, remember the absolute value sign. Why does that happen? Try to pick a color we have not used. How about green? Green's colorful. EVO, even root. Is this an even root? Yes, it is. The variables coming out, are they odd? This is an odd. That's why this one is in the absolute value. Okay. Explain why Jenna used the absolute value symbol around a to the third, but not b to the 6. The absolute value symbol is needed around a to the third to communicate, I didn't do a good job using this word, the principal root. Basically just means the most basic one, which is another way of saying which is not negative, or non-negative number. Let me choose a different color. It is not needed around b to the third because the sixth power of any real number, sorry, I put lotion on so it's a little bit, any real number is non-negative, and I can explain why. Okay, so it's saying that, you know, if the original problem was b to the 6, it would be a power function, and in a power function, x to the 6 isn't even, so it'd be flatter, right? We learned that earlier this year. And what you would have to do is only take the positive. So when you actually do the inverse, it looks like that. But for a to the third power, we already know what that looks like. A to the third looks like here in pink. But what happens is when you take the inverse, right, you rotate it and then you reflect it, it's going to look like this. And here we can only take the positive there. That's why it's the absolute value sign. Okay? All right. Let's move on to A8. All right, here we go. Last problem, last page. Rewrite the radicals by extracting all the possible roots and write your final answer in radical form. Okay, they have a 2 here. You can choose to use simplifying by radicals, or you can use rational exponents. You can choose. It doesn't matter. I'm just going to use it by radicals. So 49 is essentially 7 squared. R to the third is R to the second times R. S to the sixth, the easiest one is you couldn't break it up, but it's going to be, you can think of it as S to the, I don't know, you can write all these out. I mean, you could, but I'll just show you the long way, one way of understanding the problem. And then T to the 8th. T to the, well, let's do this one a little bit faster. What number can you write in there inside that would make it be a 4, right? 4 times 2 gives you the 8. Okay, so here you can just say then 7 R. This R doesn't have a power of 2. Do you see that? So that's going to have to stay inside the radical. The S comes out. Let's mark these off as we go along so we know. So there's an S. So how many S's? 1, 2, 3 S's can come out. And remember this one and the radical sign, so it's just T to the 4th on the outside. And that's our answer. But I'm going to check what our friend Eva over here. Okay, let's ask ourselves the questions. Is this an even root? Yes, it is. Which ones are variables? R, S, and T. Which one of those that are on the outside that I circled are odd? That would be the S and the T. So if the S and T which ones are odd? The R has to the first power. So those are the only 2 that are actually in the absolute value. Right there. If you want a super clean answer, you can write it like this. 7t to the fourth absolute value r s to the third times r. And that would be our answer. Okay? All right, number 9, we didn't do this problem. It's division. Perform the operations, extract all roots, and write your final answer in radical form without radicals in the denominator. So basically what we call this in math, we call this rationalizing the denominator. You want to basically get it out of the way. Now, you want to think of a number, so when I multiply it, it's basically gone. Okay? And that number you're going to pick is the fourth root of t to the third. The fourth root of t to the third. You see, the something over itself equals 1, right? I can just cancel that. But what you're using here is, you'll notice that when we multiply, the radicals are going to go away. So I'm going to change these to rational exponents. So that would be t to the 1/3 times t to the 3/4. And the denominator will be 8 times t to the 1/4 times t to the 3/4. Did you see why I chose 3/4? Because basically, if you think about it, the 1/4 plus 3/4 are going to go away. Watch. So 3t, you have the same base, you can add the exponents. Okay, let me say that again. Same base, you add the exponent, right? If you do something like this, this is just a to the 1 plus 2, this gives you a to the third, right? So 1/3 plus 1/4 are not common, so let's do it here. And I'm going to multiply this side by 4/4, and this side by 3/3. What I'm doing here is I'm trying to get a common denominator. So multiply across, you get 4/12 plus 3/12, and now we have the same, so 4 plus 3/12 gives me 7/12. 7/12. Of course the textbook forgot to tell us something. They always do that. 3. No, that was right. 3/4. And 1/3 to, oh, that was my fault. It was 3/4. Yeah, that's my fault. Not textbook. I make mistakes too. Alright, 3/4 multiplied by 3/3. So 4/12 plus 9/12 gives us 13/12. That's right. Okay, in the denominator now, 1/4 plus 3/4, you should just see that you can add across, because you have the same denominator, 4/4, which is just 1. So let's go over here and now simplify. I have 3. How would you simplify that one? So 3t to the 12/12, t to the 1/12, all over a to the, now we can just call that t, right? And same thing over here, this is just 1. So 3, sorry, no motion on my screen. 3t and t to the 1/12 over 8t. And then these will cancel, and we're left with 3 to 12th root of t, radical t over 8 is my answer. Because it's told us to write that in extract all roots, write your answer in radical form. Radical form just means that you have a radical as your answer. Okay, number 10, we didn't do this one. So you can skip this one, but combine like terms if possible and write your answer in radical form. So essentially what you want to have here, let's just see if you can simplify these, right? So I have the cube root of z, cube root of negative 5 to the third power times radical cube root of z plus the cube root of 512. Let's see if we can get lucky over here. 512 math. Really, does it make sense? 8 to the third power means 512. 8 times 8 times 8 equals 512. So that would be cube root of 8 to the third times cube root of z. Okay, so let's just simplify this. These will cancel, so you're just left with a negative 5 here, and you're left with an 8 here. And so really, I'm going to make this cube root of z to the third power plus cube root of z plus cube root of z. And all you're doing here is just combining like terms. You're just adding the numbers in front. So 1 minus 5 is negative 4. Negative 4 plus 8 is 4. 4 cube root of z is our answer. All right, number 11. Solve the equation. Okay, I'm going to see if I can first isolate the radical sign. And remember, I'll just start my little trick here. Normally, you would simplify using PEMDAS, but if you are, let me put this one here, if you are solving, you're going to do this in some ways to help you isolate the variable. So we're going to subtract 5. Let's put down our, this will cancel, and you're left with 2, and 2 times the 4th root of x. Okay, and right there is multiplication, so I'm going to divide by 2. You're going to get the 4th root of x. It's really a 1 right here, right? But we never write 1 times something. And this side is a 1. Don't say nothing. Don't say 0. And then I'm just going to identify the root. The root is 4, so I do that to the power. So you will get, this cancels, cancels, cancels. You're left with x equals 1 times 1 times 1 times 1 is 1. Okay, check your answer. Check. 2 times 4 to the 1 plus 5 does it equal 7. So we just said that equals 1, so 2 times 1 plus 5. So that would be 2 plus 5, and 2 plus equals 7. So that does check out. 11a is solved. X equals 1 is our solution. There are no extraneous solutions. Okay. 11b. Same thing. I'm going to put radical sign. Okay, the radical sign's already isolated, so I just need to find the root. And the root is 3, so I'm just going to cube both sides. So this 3, and 3 cancel. Again, the reason why that works, if you're ever wondering, x plus 2 to the first power to the third. If you write it as a rational, x plus 2 to the 1/3, and then if you multiply it by 3, 3 over 3 is just 1. So you're just left with x plus 2. Does that make sense? Hopefully that makes sense, because that's what's happening. So we're just left with x plus 2. 3 to the third power is not 9, it is 27. 3 times 3 times 3 is 27. And then you subtract 2, then you have x equals 25. Let's go and check that answer. Da-da-da. Okay, so 25 plus 2 equals 3. So that equals 27. And 27 is equal to a cube root of 27 is 3. so that one does work. All right, let's try this one over here. Okay, for this one, again, you're going to isolate the radical sign. So I'm going to subtract x from both sides. Just this one. So now I have the cube square root equals 12 minus x. Okay, now I want to get rid of that square root. So the index is what? A 2. So I'm going to have to square both sides. Okay. Boom, boom, boom. Gone. So you're just going to be left with x on this side. Okay, 12 minus x squared means there's 2 of these. Yes? So this is going to be multiplying with FOIL in our box. Are you following me? 12. 12. Let me pause. I need to wipe my screen. All right, let's try that again. So we are multiplying 12 minus x. No. I don't know if something's on my screen. It's right down here. 12. No. Well, you can visualize it's a 12, so 144. I think I just can't work on that side of the screen. Let's try over here. We have plenty of space. Alright, 144, so we're multiplying, then adding. Negative 12x, positive x squared. So if you combine like terms, on one side we're going to have x equals x squared. Negative 12x minus 12x is minus 24x plus 144. And if we subtract the x, we're going to get 0 equals x squared minus 25x plus 144. All right, let's see if this is factorable. Remember a, b, and c? A times c is 144. My b value is negative 25. I'm going to write all the numbers on the side to help me visualize. 2277. How about 4? 4 goes into 14 3 times, and then 4 goes into 24 8 times. No, that doesn't work. Try that again. 4 goes into 14 3 times. 2 extra through. Can I not multiply? I can't think, guys. Brain fart. 144 divided by 4 gives you 36. 4 goes into 24 6 times. Duh. Okay. How about 9? 9 goes into 14 once, and remainder 5. 9 goes into 54 6 times. And I think that's our winner. 16 and 9. I want those to be negative, so both negative. Remember, I don't need to use the box because the big idea you should be learning this year is that in my method of factoring is that your a value is equal to 1. When your a value is greater than 1, right there, then you would use the box. So, zero product rule, x equals 16, x equals 9 is our two solutions. All right, we're not done yet. Guess what? You need to check your answers. I know. So let's do it over here. Square root of x plus, and I'll do it twice. So our two solutions were, don't check that, 9 and 16. All right, let's try 9. Nine plus square root of 9 is 3, and 12 equals 12. Does that work? Yeah, that works. All right, let's try 16. 16 plus square root of 16 equals 12. 16 plus square root of 16 is 4. Uh-oh, 20 equals 12. Uh-oh, no. That means that 16 is not a solution. This is an extraneous solution. Does that make sense? The only solution in this problem is 9. Okay? And basically how that works out is if you actually graph that, x plus, because remember, basically it's a quadratic function. This one in pink right here. But remember, if you do all of our tricks to it, right, you have to restrict the domain. You have to have just this portion. What's basically happening is that x equals 16 is kind of happening in this portion in some ways, and it's kind of like the wrong way. It's like, I don't know, I'm old school guy, so it's like putting your video game system, but putting that video game into the toilet. Will it work? No. Or if I'm making coffee and I really need my coffee and sugar and my creamer in my coffee, and let's just say I'm so tired I pour it down the drain of the sink. It doesn't work, right? It's not getting in there. So that's the kind of idea. It's not getting in there. It's extraneous. It's not working. All right, last one. Word problem. In medicine, the body surface area is used to help determine proper dosage for medications. The equation is BSA. Let me write that down. BSA equals square root of W times H. Okay, now pay attention. That 60 is not in the radical. That's why I wanted to point out. Model's relationship between BSA in square meters and the patient's weight, and the patient's height in centimeters. Okay, determine the height. So that was here. So that's H equals. We're solving for this letter H. To the nearest tenth of a centimeter of a patient who weighs 55 kilograms. So weighs, came up here, that's W. That's what I have. So I'm going to put in 55 right there. And we're solving for that H over 60. Okay, pay attention. I said the 60 is not inside the radical side. So the radical sign is not isolated. I'm going to multiply both sides by 60. Oh, I forgot something. And the BSA, I was thinking about this. Okay, so I just want to throw out, this is what I was doing. I was like, this problem doesn't make sense because you have two unknown variables. Well, BSA is one variable and the H is the other one, so that's why I knew I was missing some information. So if you ever do that, go back. BSA is 1.5. So I can use this magic. 1.5. Okay, so what happens over here? My 60s go away. Okay, now normally you guys would start computing, but I do something in my class called a calculator rate equation. I'm not going to actually use the calculator to the very end. So that way you're just using the algebra and you're not dealing with a lot of decimals, which could be a mistake. All right, I'm going to square both sides because that's a 2, right? So this goes away, this goes away, this goes away. And so you're left with 60 times 1.5, and whatever that answer is, you're going to square it. Remember, parentheses and brackets mean the same thing. And you're left with 55 times H. And of course, we ran out of space, but we can do magic. Are you guys impressed with my magic? Come on. Okay, now I just need to get rid of that 55. I'm going to divide the 55. Now, notice that 55 is not in the squaring, yes? So H is our answer. Let me take a picture of this, and I'll show you how I put it into the calculator. All right. All right, you can do this just old school. So let me parentheses 60
times 1.5 parentheses squared. Okay, now you can just press enter and then don't touch anything, press divide. So it already has the answer by 55. And I want a decimal. Okay, 147.27. 147. Uh-oh, where are we? Last page. 147. What did I say? 27? And it says round to the nearest, determine the height to the nearest tenth. So the tenth is this spot, so I have to look at this number, which is a 7, and I'm going to round up, so h equals blah, 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 147.3 centimeters tall. There it is, guys. That's the practice test. We'll see you guys. Bye.